Discovery plugin, you're going to get a couple of new applications over here on the left-hand side of your screen. Discovery, Discovery Definition, and another one called mid-servers. So mid-server application gives you a place to go and download your mid-server. Your mid-server is the agentless probe that does the remote logons. So in a typical implementation, you'll have many of these things. We use them for load balancing and failover. We put them in different geographical locations, behind firewalls. The only real requirement for the mid server is it needs outbound access to the internet on port 443. So let's talk a little bit about the Discovery and the Discovery Definition app. So there's a couple of modules in here that I wanted to point out. Here's a list of all of the mid servers. As I mentioned, you'll have many of these in a production implementation. Mid servers are tied to Discovery schedules. So here I have a schedule that does a Class C network for the lab back in San Diego. And I have assigned this mid server to run that schedule. And as you can see, it's just a simple Class C network. Credentials. Another big piece of this puzzle is the credentials. So you can see here the various types. If you click the New button, pull down the drop down, you can see that it's SSH or SSH with a private key. SNMP read-only community strings for network gear and printers. Obviously your Windows credentials. Read-only credentials for vCenter will get us access to your VMware environment. And then SIM credentials are used for discovering storage and ESX serial numbers. So once I have mid-servers, credentials, and discovery schedules, those are the three main ingredients I need to get a discovery running. Down here in outputs and artifacts, these are some of the things that are created by Discovery. I use this table quite a bit when I'm trying to figure out which process to use for mapping applications. The TCP connections table is the raw data behind the application dependency mapping. It has every connection from every process from every machine we've discovered. So I will use this table sometimes to go and try to figure out what the name of an executable is that's connecting to a database or a web server or an app server. So if I come in here and do some searching, I want to find something with a 2 port. It's 3306. I just happen to know that that's the port MySQL listens on, so I can find every machine that connects to a MySQL database. I don't care about local connections, so let's get rid of the locals, loopbacks. And here's one connection I have left. This machine with this PID has a Java command that's connecting to port 3306. Alright, so let's talk a little bit about discovery definition. So this is more, while the discovery is the day-to-day stuff, discovery definition has the probes and the sensors and the port codes and the classification rules. So the workhorses of discovery are probes and sensors. Let's see here, we've got about 135 probes out of the box. They're broken up by flavor of OS. So once we find an IP address that's alive, we look for some specific ports that are open. So if port 22 is open, it's probably some flavor of Unix, and we're going to log in with our Unix credentials and run a uname -a. And now we'll know what flavor of Unix we're dealing with, and we'll branch off and run scripts specific to that flavor. So for an AIX machine, these are all the probes that are going to get fired. If I go and look at my Windows probes, these are all the probes that are going to get fired. For SSH, it's typically an SSH connection, and we're running some commands that gather the data. With Windows, almost everything comes out of WMI, with the exception of a few cases where we go to the registry. One of those is to pull the installed software, and the other one is to pull Mac printers, 3 actually, and then the last logged in user. We'll take that last logged in user and try to match that up against a user in our user table, which is populated from your Active Directory in our LDAP. So then we'll populate the assigned to field on the computer form, and we can match a person to a computer. So there's the probes. For every probe that fires, there's a sensor that processes that information. You see right here when we pull back the OS information for Windows, these are the fields that we go after. So we're pulling back the computer system manufacturer, the model, the username, the version, the description. All that data gets fed into a sensor where all the actual work is done. Alright, so that was discovery definition. Let's go back and let's run a discovery. So I have that schedule here for the San Diego lab. I'm going to bring it up, and we're just going to execute it now. You have the ability to say discover now, or over here you can have it run. In this case, it runs every morning at 8 o'clock. We're going to run it now. And this is going to create a status record. So the status records is a running history of everything that happened during this discovery. In fact, if I go to discovery status, I get a list of all my status records, and I can go back and see how last night's job ran or last week's job ran. If I drill into one of these status records, I can see the devices that were discovered during that discovery, and any errors or warnings or anything that went on during discovery that I would want to know about. So I have the relevant pieces of the log here. I have the devices that were discovered, so 2 Linux machines, a Windows server, and 2 ESX servers. The ECC queue is the messaging queue that sits in between the probes and the sensors. So these are all the questions and the answers. The outputs are questions, the inputs are answers. So I'll usually come here and I'll say show matching on input so I can see all the answers to the questions I asked. So for example, if I look at, let's look at my WMI classifier. So once this is one of the first probes that runs on a Windows machine to figure out what this thing is, what OS it is. So if I drill into this record, this is the XML payload that the mid server captured and sent back to the sensor for processing. So you can see here we got the host name out of the registry. We checked a few times to see if it was a cluster server. And now we're pulling back the work group, the host name as it is in VMnet, WMI, the operating system capture. So there's little bits of data through this file that the sensor is going to parse out and create the new record for this computer. So let's go back and let's check out one of the servers that was discovered via this discovery schedule. So we'll look at our vCenter server. And bear with me while this runs. There's a lot of CI relationships hanging off of this vCenter server. It does a number of things. It's an Exchange server, our AD server, and also has vCenter running on it. And here we go. So we pull back the host name. These are 2 different host names. One comes from WMI and one comes from the registry. Down here I have the CI relationships. So down here at the bottom I can see this server runs a bunch of mid servers. It also has a SharePoint connection tool. It's running an IIS server. It's running 2 instances of MySQL in the vCenter. Up here are all things that are related to the things that are local. So up here, the vCenter has 2 data centers, a production and a development. The IIS server has 5 websites. The SharePoint website, it's got the default website. It's being used by 2 business services. I'm going to talk about this last. It's also being used by applications. So here was the mid server discovering vCenter. Here's the SharePoint connection pool talking to a backend MySQL database. This happened automatically because we knew about both of these executables. So when we ran netstat against this machine, I was able to connect the dots and say, I have an application called SharePoint connection pool, which depends on the SharePoint database running on the vCenter server. Here's the whole 3 tiers of an application. Here I have a website that depends on a connection pool, which depends on a backend SQL Server database. So those are called CI relationships, and if I keep on scrolling down, I have baseline differences and schedule changes. So you see here I have a change schedule to take this service pack to service pack 2. Notice it's on service pack 1 now. Once I go through that change and affect the change, verify the change, and actually close the loop on that change, this schedule change will move up here to a baseline difference. So baseline differences are broken into 3 categories. You have basic attributes. You can see here the OS service pack has changed a few times. Here it was 2. If it was 2, it was 3. Here's another example of me changing it around during another demo. And lastly, here's one I did through change management. The OS service pack is 2, it was 1, and it was changed via this change request. Notice these guys don't have a change request, so that means they were just unplanned changes. Discovery found them, reported it against a baseline, but there was no corresponding change request. The second one are relationship changes. So there are things being added and removed from this server all the time. And if I look at, they get broken up into categories. So either added or removed. Here I see something was removed. So this machine was used by SAP Financial Accounting, and I removed that relationship. So we have another one. I removed all of these websites. These websites have disappeared from one discovery to another. That's relationship changes. And lastly are related CIs. So this Windows server is related to the databases, the IIS server. Everything basically you see down here is related to this server. So it's having things that are changing on it. So here I can see here was a change for the SharePoint connection pool. And I can see the threads were changed. If I drill into that, I can see the threads were 15. The threads are 15, they were 20. Here the threads are 20, they were 15, and this was changed via change management. This was outside of change management. So 3 categories for baselines, and then we talked about the schedule change. I'm going to leave this out here for a minute because that is going to be a conflicting change. So we'll leave that guy right there. Down here I have all the related lists for this server. The network adapters, the disks, the running processes, the serial numbers. We pull back 5 serial numbers on a given Windows server. We use these for our reconciliation rules. Over here, memory modules, the software that's installed. This is the data that comes out of the registry. And lastly, I have the TCP connections just for this specific server. This isn't all of them. In production, you probably wouldn't show this, but I like to use this when I'm setting up discovery dependency mapping so I can see all of the connections that this machine is making to other connections. So I like to come in here and filter out the listening processes, and now I can see just the established connections. You can see this is all our VMware stuff. Established connections from IP or from port and to IP or to port. Each one of these lines is a half a connection. Once I discover the other side of this and figure out what was on that port, as long as I have process classifiers for both sides of the relationship, it'll automatically be included up here as a nice graphical CI relationship. All right, let's see how we might use, actually I want to talk a little bit about business service mapping. So we have found these servers, we found all of these applications and relationships, but now I'd like to tie these to the services they support. So I've done that up here under configuration. I've got 2 business services that I've created. One is called SharePoint. Let's get those out of the way for now. So this is all manually entered data up top here. This field right here is critical within change management. So if I were to make a change to any of these underlying configuration items, and I say, go check my risk, it's going to go to the CMDB, traverse all the way up to the business service level, and check to see if the services that the particular CI supports has a business criticality of 1 or most critical. If it does, we're going to mark this as a very high-risk change, and that could even send out for some further approvals based on making this change. So to set this map up, I basically had to go and tie my business service in somewhere. So, and I did it right here. This is the piece of data I added was SharePoint depends on the SharePoint Central Admin site. Everything else you see is related to this site. This is the website, it has a connection pool, and it has a back-end database. So I can look at this graphically by clicking the little org chart looking button. So here's SharePoint. I manually defined this relationship. This depends on. Everything else to the right of this was automatic. So we already knew that this website ran underneath the IIS server. We know it runs on this server, and we know that this server talks to this database. I'm sorry, down here. The website connects to the connection pool. The connection pool talks to the MySQL database. All of this stuff runs on this Windows server called vCenter Server. So that's one business service, and you can nest business service as well. So if I jump up a level, I also have this overarching business service called the Online Customer Portal. And I said it depends on SharePoint. SharePoint's being used by the Online Customer Portal. So this is the, like I said, the overarching business service, and it depends on SharePoint, so I added that. And it also depends on a web application that runs underneath the Tomcat instance called e-commerce. So I added that as well. But again, I did that by going to my relationship creator, and I wanted a depends on relationship. And I added these 2 pieces of data. E-commerce and SharePoint. And I pulled these out of the slush bucket over there using these filters to go and narrow down the things that are allowed to use the depends on relationship. And again, that is all I added. Everything else you see in that map is related to e-commerce or it's related to SharePoint. And if we look at this graphically, I get a nice graphical picture of the overarching service. It depends on SharePoint and e-commerce. Here's the SharePoint branch we looked at earlier. Here's the e-commerce branch. The web application runs under a Tomcat. The Tomcat talks to a Linux server. The Tomcat runs on a Linux server, and it depends on a MySQL database. So again, this was one of the relationships created automatically by Discovery, since we had process classifiers for Tomcat and we had process classifiers for the MySQL instance. We built that automatically based on the results of the LSOF command. We built this relationship automatically based on the results of the netstat command. So let's see how I would use this business service through incident, problem, and change. So let's go open up an incident. I'm going to open this on SharePoint. So we'll say Dan is calling in today about performance problems on and let's say this guy. Oops. Left out a key piece of data. We have to actually put a configuration item in here. So here's my SharePoint business service we looked at earlier. Let me save this. So from the incident form, I can access that map that I showed you just a minute ago by rolling over this icon right here. So that is a decoration that will bring up the business service map for SharePoint. If I hold my shift key down, I can make it stay up there. Same thing we saw earlier. Just a read-only view. I can see the dependencies. I can see upstream. I can see downstream. Right here, I can see that we've got some things going on. We saw that plan change earlier. That was to take the service pack to a new version. The red dot indicates an incident. The stoplight indicates a problem. So incidents, problems, and changes automatically map to configuration items. There's also a declaration for outages as well. And when it comes to outages and changes, they have a planned start and a planned end date. So we can apply a little further logic and determine if that's a planned change, an open change, or a recently closed change or outage. So if I'm diagnosing performance problems, I would like to know what's changed recently. And this map gives you that visibility to go in and look for recently closed change requests. So let's go, now the service desk is getting numerous calls about performance problems with SharePoint, so let's go into problem management. So I'm going to go create a problem for you. Nope. All right, let's bear with me 1 second. We'll find that incident again, and we'll create it. Oh, actually, it did create a problem. So let's go back. Let's go to the problem, and we'll pick up where I left off. Performance problems on SharePoint. Now I'm going to use my BSM map to go in and focus on what the real problem is. The problem's not on SharePoint. It's going to be on something on the underlying infrastructure. So let's look at the graphical map, and we'll say that the problem management guys have determined what the problem is, and the SharePoint connection pool needs more threads. So we're going to say set that as the CI, and we'll save it. And then we're going to go into change management. Okay, so we know that we need to modify the threads on the connection pool. So it's going to go right click, create change. Now there's all kinds of things I can do now once I'm in change management and I have a configuration item on my form. First thing I need to do is put a date in here. So let's put a requested by date. We'll need this by the end of the month. We're going to try to do it. We'll try to do it tomorrow. So this is going to take a couple hours. Save that. So notice the related links down here. So I can fill out a risk assessment. I can execute my risk calculation. And actually, let's set a category here so that we can force the risk assessment to be filled out. The risk assessments fire based on categories. So if you're making a change to software, I'm going to ask you a bunch of software-related questions, and we're going to take your answers and derive a score. That score is going to determine the impact and the risk. So let's fill out our risk assessment. I'm going to take the defaults here. This is completely configurable. You can change the questions, the answers, and the rating behind them. We're just going to go with the defaults, and that's one component of my risk. There's also some other things I need to check. Do I have 3 days lead time? Am I changing the CI that affects a critical business service? So let's execute our risk calculation. And it's going to look at two things, one being the assessment, and the second being our rules. So the assessment was evaluated, and we got a high from that one. Risk equals high. We also have risk conditions. My first one it looks at is insufficient lead time. If you're not giving me 3 days lead time, I'm going to mark this as high risk. So we're going to take the higher of one of these two and set the risk to very high. So let's give them the 3 days. Let's push this out to Monday. And we'll say 7. Change the times here. This one's going to go to Monday as well. Let's save that. And we're going to execute my risk calculation again. Right now, these are set up as related links or UI actions. You can also have these as before insert business rules. So every time you try to save this form, it will execute the risk assessment, execute the risk calculation. So now we got past our 3 days lead time, and we got to our next risk condition, and it says a critical service is being affected. We already know that the SharePoint connection pool supports SharePoint, and SharePoint is a critical business service. So here I can see the world from the SharePoint connection pool's point of view. This is kind of interesting here. So I've got a version, I've got the number of threads, it's running on port 80, and I have its CI relationships. We know that the pool depends on the Microsoft SQL database. It's being used by SharePoint and the online customer portal. It's also being used by this website. Remember, the website used the connection pool depending on the SQL Server database. And all this stuff is running on our vCenter server. So now that I have a CI on here as well, I also need to propose the change. So down here I can come to the CI, and I'm going to propose the change that we're making. And we're going to have the threads on the connection pool. So this is going to bring me to a shadow record where I can propose changes on any of these fields. And I'm going to propose we take the threads to 20. And notice the button says Save Proposed Changes. This is logging a scheduled change against the vCenter the SharePoint connection pool. I'll show you that in just a second. In fact, if we come here now, put the Shift key down. This is the change that we're doing right here. This one that ends in 98, we're taking the threads to 20. So now I have a scheduled change in the system. So I'm going to come back to that. Let's do one more thing is I need to check my conflicts. Am I doing this during a maintenance window, a blackout window? Are there any other changes scheduled for this CI, its parent CI, or its child CI? This is important. I could be making a change to the SharePoint connection pool. Somebody else could be, let's say, upgrading the service pack on the server. At the same time, that's going to cause a problem. So let's check my conflicts. And lo and behold, we do have some conflicts. It set my conflict status to conflict. This is important because I have a branch in my workflow. It says, if you have a conflict, I need your manager's approval. If there was no conflict, just go ahead and go straight to the tab. So it also tells me to scroll down to see what my conflicts are about, and I have one down here. And lo and behold, the child CI is already scheduled. The vCenter server has a change on it already at the same date and time. Remember, that was the one where we were going to go and update the service pack. All right, so if you have runbook automation, also known as orchestration, we can further automate this change request. So notice the execute orchestration button. This will use our orchestration product to go and automatically affect the change for you. So these are the runbooks I'm allowed to run. I want to recycle the IIS connection pool. So this is going to call a bit of workflow that's going to do just that. All right, so lastly, we're going to close this change request out. Let's go back here. I wanted to show you one thing. So if I go back to the SharePoint connection pool, you'll see that we have a scheduled change against it. We want to check the threads to 20. So if I go back to that change request, and now that button doesn't say save proposed changes, it says apply proposed changes. We're at the end of the change has been effected and verified. We're going to go ahead and update the CMDB now. So I say apply the proposed changes. And lo and behold, we no longer have a scheduled change anymore. But if I break open my baseline differences, I will see that the threads are 20, they were 15, changed via this change request. So let's say Discovery just runs tonight and somehow they magically went back to 15. So Discovery will find it, so okay, that field changed, we'll update it and we'll save it. That still gets captured against this baseline for May 31st. Oops. But notice this, no change, change, unplanned change, planned change. All right, so one last thing I wanted to touch on, there are some direct feeds from Discovery into asset management, both hardware and software. So specifically, in software asset management, there is this notion of a Discovery models table. This table is populated automatically by Discovery with all the unique software titles we found out there. So if you choose, notice some of these are being mapped to software models. These are things I care about. So when I find these things, I need to go check for licenses and entitlements. This Fedora project and CentOS, don't really care about those, so we just captured them, put them in the Discovery Models table. Again, if you want to use these titles in asset management, you need to map them to something, a software model. That's a topic for another conversation within asset management, but notice up here you have software models, and down here you have Discovery models. Discovery models are populated automatically. Software models are something you build. This is where you get to model out what Microsoft Office or what Adobe Creative System Suite looks like in your environment. So the other place that we have integration is on the hardware side. Oh, one more thing I wanted to show you on Discovery models. So these are all the unique titles of software we found. If I drill into one of these unique titles, I can see all the instances where we found that piece of software. In this case, all of these machines below have Adobe Systems Acrobat 9.0 included. All right, so let's go to the product catalog. That's new with Calgary, and it is on the hardware side, but it has the concept of models as well. And Discovery will populate this models table with all of the unique models we found. So down here, notice there's 4 sets or 4 entries for the DX series, the gateways and manufacturer, but they're slightly different models, the 21P, the 11P, the 10P, and the 32P. So those got individual unique entries because they're different models. If I drill into one of these, I can see the instances of where we found, in this case, the 10P. So over here, this record, blue, for lack of a better word, is the record that holds together the assets and the configuration item. So we've got 4 assets, and these are the asset records that were created, and then we've got 4 configuration items. These are the CIs as they sit in the CMDB. The assets are outside of the CMDB. Obviously, the configuration items are inside the CMDB. Okay, well, that's most everything I wanted to go over today. Thank you very much for your time.